Problem number 2. Here we have overlapping triangles, and we're going to try and prove this first triangle, triangle UDC, the small one. We're going to try and prove that's similar to this bigger one, U, all the way down to S and then to T, or as they call it, UTS. And here, you can actually prove these triangles are similar with two different methods. You can prove them similar with the side-side-side method, which I'll be using, or you could do it with side-angle-side similarity. But I'm going to let you figure out whichever one you want to do. I'm going to do side-side-side because I know in the next problem I'm going to be forced to use side-angle-side. So I want to diversify and get some practice. So I'm going to do side-side-side. So I've kind of traced out the two triangles. I recommend separating them if you're having trouble seeing corresponding sides. But I'm going to focus on my small red triangle, and I'm going to look at the three sides that they give me, right? This being the base. Out of those three sides, 36 is the small, and 54 is the big. I'm going to leave 40, I'll triangle it just so you can see that those are the three sides. I can see that 36 is going to correspond to this entire side, UT, which they're saying is 42. I can also see that this 42 here is going to correspond to that 49. So triangle that. And then the last side, that 54, which is right here, well, that 54 will correspond to this entire length. It will be 54 plus this 9. That will give me 63. Right, so I'm going to make that all the way down, call that 63, rectangle them off so that they're the same. I might as well just check that my math is good, 54 and 9, yeah, 63. And we're going to make our ratios and then type them into the calculator. So we'll start with the smallest sides. That's our method so far. So I'm going to do 36 over the corresponding 42. I'm going to do the biggest now, that 54, over the corresponding 63. And last, I'm going to do the bases. So I'll do 42 divided by the corresponding 49. And these are going to be weird numbers, and that's fine. I just know that they all need to be equal. Yeah, 0.85, such and such. 54 over 63, same, and 42 over 49. So you could write out those decimals and you can approximate them to the, I don't know, nearest thousandths. 3 digits is fine. But you could also do some math, hit that math button. We're going to take our answer, hit enter. We're going to take our answer and convert it into a fraction. Because all of those fractions are really 6/7, and that's their ratio. So I want to write the ratio up as 6/7. That's just more precise and easier for me to kind of see and write out. And I'm going to be thorough, and I'm going to talk about the sides where these came from. So 36 came from that side UD. 42 came from UT. 54 came from UC. And 63 came from U all the way to S. And then last, we have our bases. I'll do them in black so you can see. DC was the 42, and TS was the 49. So I have my three sides that are in proportion, and I'm ready to write my proof. I'm lucky I can just copy and drag over. And why did I do that? Well, that's the ratio of corresponding sides. And like I said, I'm going to keep track. That's a side fact. 2, well, I did another ratio. My reason for writing that, well, that's the ratio of corresponding sides. That's a second side fact. And then once I've assembled my third fact, whatever it may be, whether an angle or a side, I'm ready to prove the claim they're asking me to prove. So this third fact was a ratio of corresponding sides, and that's a side fact. And now for, I've got my 3 facts that I need. I'm just going to restate what they say up there. That triangle UDC must be similar to triangle UTS. And how do I know that? Well, that was the side similarity postulate. When all of my sides are proportional, meaning they have equal ratios, I can conclude that those triangles must be similar. I'll see you in the next one.